Welcome everybody, you're watching Mr. Fugu Data Science. Today we're going to parse the Indeed job postings qualification section using natural language processing and, if time allows, create a word cloud depending on the length of this video. I do need to bring to your attention one thing that's quite problematic, and I don't want to throw off any of my viewers and subscribers.
I have an imposter
who took my likeness and just put in my name as their channel now. But if you pay attention to the top, this is the same person who I made a video about the other day, my little troll. Okay, so please be aware of this and understand that this is not me. This is me. You have to pay attention to the URL, and the only way you see the exact URL, you need to go on the about part. This is very important, okay? Because this person harassed me, made fake accounts, and told me they were going to dislike all of my videos. So please be aware of this person. Let's get into this video. I digress. You need a lot of imports today, okay? So I really suggest going on my GitHub and getting that. As always, it'll be in the link in the description below. Feel free to pause the video if you would like to jot this down real quick if you have interest, because there's quite a lot going on. Now, this file comes from our Indeed web scraping that I did recently, and of particular interest is this right here. This will be shown in a second for one entry. Our skills match is really interesting because I had a large or a decent sized list of skills that I matched against this text. And each one of these lists are these particular skills that were relevant that I found that were matching my skills list. And there would be a word cloud for that as well as a second word cloud. So the first entry will look like this from this company. And it has a bunch of text. And we're just trying to figure out in the end what are common between all of the text. I put each of the 225 rows into one large, you could call it a corpus, for evaluation. Okay, here's the buzzwords that I used if you were interested to evaluate against to make that skills column. Okay, this could be expanded on or customized for your own interest or your own skill set, depending on how you want to do this, but that's available. Now, to get a baseline, let's figure out a few things. I was interested in the number of words per each row, because what we're doing next is we need to start breaking this up. And there's kind of a general workflow when you're doing natural language processing, all right? The first thing when I evaluated, I noticed something interesting. When I did my word cloud, I didn't pay attention, and I noted that you need to take out anything that has a URL. This right here is going to take out anything with HTTP and anything after that. So it includes the HTTPS. So you're good to go. And what I wanted to do is figure out really, okay, is this working and how much of my data really have it? So I found yes, it is working. Now we need to actually extract it and pull this from our information, okay? So I had to throw in a if statement to work with my pattern and then find everything that's within the text for each entry. And then if you don't have a URL, I just chuck this in so we could keep the formatting aligned with the rows. Now, if I'm getting rid of this, I could just use a regular expression substitute. So I still am finding the pattern that I'm looking for, but instead, when I find that pattern, just throw in an empty string with a space. And then I make sure that my lines matched up. When you're trying to recheck this, you're basically running the same thing, but you're throwing out the else statement. Because if I throw in the else statement here, it's appending the rest of the data. But really, I'm just trying to evaluate how many rows of the pattern are still left in this data to make sure I didn't make a mistake. And if you see it, length of 0, so I didn't make a mistake here. I'm good to go. Now, comparing the length with and without the hyperlinks went like this, because I was curious, for instance, like this entry as a sanity check, what does it look like? It's actually working, yes or no? So that's what I did here, just so you can get a visual representation. Get a little bit of dialogue, you know, just like this right here. Now, the next thing that we want to do is say, all right, we got this strip data. If we want to throw it in, we can enlarge our data frame. It's unnecessary. You could just keep it as a list for the next part that we're going to do. If you notice this right here, when I created the original file that we're reading in today from the web scraping, I think I used an empty string instead of a space is why you're going to have some of these kind of issues like this. Okay, so that's just something to be aware of. This removes some punctuation and digits. Throw everything into lowercase. Get rid of the string punctuation as well as any digits and join everything together with a string join and append it into its own individual list for each entry. Okay, that's all that's going on here. Now, the next thing you need to look at is stop words, single characters, and useless stuff if you could find it, or if you have an idea of what it really is. Now, I kept 2 and 3 character words because the 2-letter abbreviations for machine learning, artificial intelligence, and deep learning are used quite frequently. And so I have to take only, 2 and up instead of 3 and up or 4 and up because you want to preserve some of those. Now, that's what's going on here with this list comprehension. And then from there, you have to notice something here. I have a double bracket because without that double bracket, it's not going to enclose this in the formatting here. It's just going to print it off as just strings separated by commas. Okay, so that's one thing you got to pay attention to. And you're just chucking in your stop words. That's from the NLTK that you import at the top. So if you want to see what the stop words really looks like, if you've never done this before, this is basically what you're looking at. Here's a bunch of the stop words. The same thing if you didn't pay attention above. Here's what your punctuation is that you're parsing out. Okay. Now we got to see as a comparison kind of what's left from what we're cleaning, and if you notice it's basically 10 times smaller. In general, you're going to have a lot of stop words or just useless things. Since I removed digits, stop words, the URLs, things like this, it started progressively getting smaller very quickly. Okay. The next thing you can do, and it depends on your situation. For instance, here I thought it would be useful to do lemmatizing. You could also do stemming, but be aware of some of the hurdles or problems that you can have with that. And I suggest you look at differences in stemming and lemmatizing. Stemming is using just like cutting off the ends of the words, whereas a lemmatizer is going to deal with actually a rule-based approach. Okay, and there's different lemmatizers and stemmers. Now, what I wanted to do is, since this is a list of lists, I needed to get inside of all of that. And I wanted to preserve the index position, that's what I is, and take my actual word, which is J, and throw it into a default dictionary that I could actually use for what we're going to have in a second. Let me show you. Okay, so this is the first entry for a first row with all of the words that are separated. That's what's going on. And I have it for each one of them, each one of the rows, 225. But really, I just need the values of it. Okay, so then after we get the values, I wanted to check, okay, make sure the length of this didn't change, which it should not, because it's keeping the same word. It's just affecting the ending. Okay, I printed this off so you can understand what's going on with that. I threw it into the data frame, so now we could have this, which we're going to use next. So let's backtrack and think about what we just did as a workflow. I had to figure out, one, is there anything that's odd that I need to take care of? The first odd thing I found, which was the hyperlinks that needed to be taken out because those are just going to cause more confusion and more useless words when split. Second, you start looking for stop words. If you have a text, you want to split that into tokens, tokenizing. So you could tokenize and split it into either sentences or individual words. Usually what you'll do is then you will decide, do I have to take out digits? Do I need to take out any other words that were not inside of the stop words? So you're making a separate list or dictionary for you to do further processing. We have something that's interesting. The Lemmantizer, you would think, would adjust for something like this, all right? But that's not the case, okay? Because anything with cyan comes back and allows me to see that it was not changed. And I didn't realize this until I ran one of the word class to understand that there's actually a problem here. And this is something that you can come back to and rectify, which I would suggest, or deal with it and explain the discrepancy if need be, okay? So we needed to convert our list of lists into just a single large string. And so I had to iterate inside of this because it's a list of lists. That's why there's the two loops. And then I want to come back and throw this into just a data frame. You can also do a direct pandas function. I think that's what it is explode, but don't quote me on that. And then from there, I took that one big list of words here and just converted into a large string that we're using for our processing. Then I figured, how about I start looking at the frequency of words to start seeing if there's anything in particular that might throw off my word cloud later, because that's what you're working with, is you're basically using a word frequency to dictate basically how large the word's going to be in the plot, is how you can think of it. So basically data, of course, that's going to be one of the biggest things in there, and science from data science, or maybe it's part of an education requirement, some kind of science background. It's hard to tell unless you looked independently at each posting. But here, you could use this as kind of like a tool to say, hey, I sorted this out. Let's look at some of the really strong, highly captivating word frequencies and see if there's anything in particular that's highly useless, and I could just chuck that out in further processing, okay? But I hope this brought utility to someone. Please like, share, and subscribe. And if you subscribe, turn on that notification bell. And remember, do not go to this person's site who is an imposter. They're faking to be me.
They're mad at me.
Because I made the video.
And I apologize, but that's how it goes, man. So please change your profile picture and don't try to be me.
You're not me.
And don't try to be me. You're not me. You're not gonna be me. You're not me. So please don't try to throw any more animosity, because I'm just gonna throw shade. Don't be a troll. You're always gonna have haters trying to take you down, no matter what you do. But you just keep on trucking, because there's always gonna be trolls. So have a good day, Mr. Nobody, because you're not me. This is me.